This is a video of how to work problem 6 out of the homework for section 4.2. It gives us a data set where X is the commute time and Y is the well-being index score. We see from part A that we're supposed to find the least squared regression line. And so we need to put this data into our calculator. So you can see here that I've already done that part. I've got all of the data for X in list 1 and all of the data for Y in list 2. So to perform a linear regression, the first thing we want to do is make sure the diagnostic is on for your calculator. So to do that, we hit second and we hit 0 to take us to the catalog. To make sure the diagnostic is on, we have to go all the way down to letter D. So I have two choices here, diagnostic off, diagnostic on. So you want your little triangle pointing to diagnostic on, you want to hit enter, and then enter one more time, and then your calculator says that the diagnostic is on. So from here, if we're wanting to perform a linear regression, we hit statistics, SAT for stat right here. Then we need to use this arrow to take us to calculate. We want to calculate number 4. So you can either scroll down with your down arrows to highlight number 4 and hit enter, or you can just touch the number 4 and it'll do the same thing. So once this is back on the home screen, we hit enter, and here we see our linear regression. So let's go back to our problem here. It says to round to 3 decimal places as needed. So when we go and we get our values out of the calculator, we'll round to 3 decimal places. Okay. So y equals ax plus b means the slope is negative 0.085 x, and our b, our y-intercept, is positive 68.988. Okay, these are both rounded to the 3rd decimal place. So when we go back to MyLabStat, we type in these values. Check answer, and we're ready for the next step. Interpret the slope and the y-intercept if appropriate. So we're going to interpret the slope first. Select the correct choice below, and if necessary, fill in the box to complete your choice. So our slope is negative. So for every unit increase in commute time, which is x, for every unit increase in commute time, the index score is going to fall. So we want choice B. For every unit increase in commute time, the index score falls by 0.085. On average. Okay, so since the wording already says that the index score falls, you can leave off the negative. So we're ready to interpret the y-intercept. So for this problem, we are looking at x, which is commute time in minutes. And so if our commute time is 0 minutes, then that means our index score will be predicted to be 68.988. Okay, so it is appropriate to look at the y-intercept for this problem because it is reasonable that your commute time could be 0 minutes. It could take you less than a minute to get to work. So it's reasonable to interpret the y-intercept for this. So when we plug a 0 in for the x of our y hat, then our y-intercept is interpreted as an index score of 68.988 for a commute time of 0 minutes. Okay, part C, the next thing we want to do is predict the well-being of a person whose commute time is 25 minutes. So we'll need our calculator again for this. So what you're doing is you're given that x equals 25. Okay, so you're going to substitute that in for x into the y hat regression line. Okay, so if I type all of that into the calculator, it gives me a result for y that is equal to 66.863. And this is y hat. So if I go back to Pearson, the predicted index, or well-being index of a person whose commute is 25 minutes is 66.863. Okay, so it's predicted because we used y hat to predict it. Okay, we substituted an x value into y hat. We got a value out that was 66.863. And it actually says only round to 1 decimal place as needed, so I don't need anything but 66.9. Okay. Suppose Barbara has a 20-minute commute and scores 66.6 on the survey. Is Barbara more well off than the typical individual who has a 20-minute commute? Select the correct choice below and fill in the answer box to complete your choice. So on this one, we're looking for the residual. We have observed that for a 20-minute commute, it's 66.6 on the index survey. So our observation x, observed x, is 20 minutes, and our observed y is 66.6 on the index. Okay, so we want to know, is Barbara more well off than the typical individual who has a 20-minute commute? So what we want to know is, what does the line predict for a 20-minute commute? So what does y hat say about a 20-minute commute? Y hat for a 20-minute commute. Okay, so negative 0.085 times 20 plus 68.988. Okay, the observed y value is 66.6. The predicted y value is 67.288. So what we do from here in order to find the residual, we take the observed and we subtract the predicted. So the observed was 66.6 and the predicted was 67.288. So 66.6 minus 67.288 is a negative 0.688. That means that the observed value, because it's negative, that means the observed value falls below the average value or the predicted value. So I need to go back to Pearson. So because it's below the predicted value, this means that Barbara is less well off because her commute score is she's less well off because the typical commute score, or the score for a 20-minute commute, is 67. We're supposed to round to one decimal place, 67.3.